Welcome back, as we now demonstrate typical jointing procedures. The practice of joining copper tubing is a very common task that all technicians will have to perform. One of the most commonly used joints is one called a swaged joint. This joint is one where tubing of the same size is permanently joined using a brazing process. There are two steps involved in creating this type of joint, namely the swaging procedure and the brazing procedure. Swaging involves enlarging the inner diameter of one tube to match the outer diameter of the mating tube. This is easily achieved with soft-drawn tubing. The tools required are all provided in this flaring and swaging kit. In similar fashion to flaring, the tube is fitted and held in the clamp block. This time, however, we leave a protrusion of approximately that of the tube diameter. Next, the swaging punch, which matches the tube size, is selected. The punch is attached to the forcing screw, and then the yoke is fitted, as we did with flaring, to the clamp. Swaging or spreading occurs as the punch is forced down into the tube opening. When the punch has bottomed out, we unscrew the forcing screw and remove the tube from the clamp bar. A trial assembly is made to ensure that we have a neat fit. Remember that the depth of the enlarged section should be at least that of the tube diameter. This will ensure a strong mechanical join. To perform the brazing operation, you should be familiar with the correct and safe use of gas welding apparatus. Although a swage may be performed directly on a unit, for demonstration purposes we'll work on our workbench. Because we are going to join copper to copper, we shall use copper alloy filler rods. The term copper welding is sometimes used to describe the following operation. Note that this process requires no flux. The process is dependent on applying the correct amount of heat using a correctly adjusted flame and a suitable nozzle size. We begin by heating the joint as evenly as possible. This should be done until the joint area glows a cherry red color. At this time, we'll apply the filler rod to the joint, where, if the temperature is correct, a melt will occur, causing the alloy to flow into and around the join area. Now, the secret of a successful flow of copper alloy is to keep the heat just right and in the area of the swage. As molten alloy tends to flow toward the hotter area, we can draw it into the joint by concentrating the heat toward the swaged portion. A join is only considered gas-tight when all of the tiny cavity between the two joined tubes has been completely filled. Let us look at some illustrations showing poor joints. In this example, the fill has not fully surrounded the cavity. A small area with no filler is the result of not evenly heating all round. In this sectional example, the alloy has merely blobbed over the joint but has not penetrated sufficiently. This joint may not leak initially, but it is mechanically weak and the fill will crack if subjected to vibration or mechanical stress. This problem occurs owing to the heat being concentrated too far away from the swaged end. In this example, commonly called overfill, an excess of alloy has been drawn into the joint and caused a restriction. This is bad in terms of refrigerant flow and contamination trapping. The cause of this problem is generally that the tubes were not fully interconnected and too much heat draw was given toward the swaged end. If you follow the recommendations we've demonstrated and gain a little practice, you will soon be able to create a neat and trouble-free swage joint. For best results, it is advisable to allow a brazed joint to cool naturally. After the break, we'll demonstrate how to join tubes of different diameters.